I've assembled this into a script to build the attack string as well. So we have the address of that gadget 1 that pops 6 words, gadget 2 that moves RBX into RAX. We will need to predict where name is going to be on the stack. And then inside of showDate, we have that address the same as before, and we build up this name to feed into our program. So let's go out. I'm going to run Python of, well, just to show you, that is the same script that we had on the slide. So Python into name. And let's step through this. It's not going to quite work as I've set it up because it turns out my buffer on the stack prediction is going to be wrong. But let's watch it anyway. So we're going to break at main. We're going to start running the program. And we want to stop in the usual place inside of say hello. So that usual place is this return right here. So my attack has gotten loaded in, and if I look at the first thing that's on the stack, we see this number here, and that number is at the end of fgetS. So 3191, if I disassemble fgetS, we see the 3191 is our gadget right there. So that's the first thing on the stack. The next thing on the stack, which this gadget is going to move into RBX, is that address, which we were hoping would be the buffer on the stack, but we see that it's not. In fact, if we look at RSP right now, then we see that it's a 30412 A4C8. Anyway, it's far from this address here. In fact, somewhat helpfully, our program has debugging information printed where the name buffer actually was. It was actually at this address. So since that address is different than what we set up, let's try again. I'm going to modify my script here to put this new address, different than the old one. Run the script again. Try again, breaking at main. Reminding myself where I want to be inside of say hello. That's here. Continuing to there. Now we see that the buffer ended up being where we expected it to be. So if I try again, printing out things that are on the stack, I see that we have the code inside of fgetS, but now we have bin bash as the next thing on the stack. So as we step through and jump to gadget 1, we see that first thing it does is pop the thing remaining on the stack and put it into RBX. So now, if we look at RBX, it has the string in it that we wanted. And now we're going to step through some other pops, and eventually we get to a return here. But the thing that's on the stack now that we pack some other things off is this address that is again inside of fgetS, referring to gadget 2. So when we step to gadget 2, we see that RBX is getting moved into RAX. If I take a step, then I can print the string at RAX, and we've got bin bash there. Gadget 2 is going to do a bunch of other things that we don't really care about, just collateral damage to a bunch of other registers. But now when we return, the return address that's on the stack now is our EBB address that's in the middle of showDate. So when we step there, we can see that RAX is going to get moved into place, and we will eventually call bash. So step through, and we get to the point where we're about to call execve. We can print what's in the first argument RDI, and we see that it will run bin bash. Except it won't run bin bash because, again, we get terminated due to signal 5 since we're in the debugger. If I try to run not in the debugger, then we will see that every time I run, the buffer exists at a different location. So address-based randomization is doing its job and preventing us from breaking in. If we did not have that, so I've got a run no ASLR helper function to turn off address-based randomization. And now when I run it, we're still not getting a shell because the address where the buffer is not where our script currently predicts it. So let's edit that one more time. Send it to this new, didn't copy the address, to this new address. Run the Python script. And there we go. We managed to run bash through our attack instead of sh.